So rectangular coordinates section 1.9 talks about the coordinate planes. We take our traditional x-axis. We say if that is the center of it, to the right positive, to the left negative. We add another axis, a vertical axis. We call that the y. We still match that as 0. Going up, we select that to be positive, and running down, we select that to be negative. Anytime I draw the line and I don't really label anything, that means those are 1 units each. If it's anything other than 1, I would have to label it. So a point in rectangular coordinates is given by x first, then y. So in this quadrant right here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. A point in the first quadrant, x must be positive and y must be positive. If I have a point in the second quadrant, x must be negative, y must be positive. For any point to exist in quadrant 3, both the x and the y must be negative. And for a point to be in quadrant 4, you must move to the right and you must move down. This is the origin. And the coordinates for the origin is 0, 0. That's kind of like a start. That's where you start every time. And the next example talks about how to plot some points. So this is a quick refresher. Example 1, plot the following points. So 1, 3, I would move 1 to the right and 3 up. That would be A. B would be 2 to the right, 3 down. Assuming those are 1 each, that's B. That is in quadrant 4. C, you would move 1 to the left, 1, 2, 3, 4 up. Point C is in quadrant 2. Now, this says do not move in the x direction. So remember, you start there. You don't move right or left, but you move down 2.5, 2.5 units. That would be D. And, oops, that would be D. And for the last point, negative 3/2, that's negative 1, negative 2, negative 1.5, and negative 1 and 1/3. That should be E. Keep in mind, anytime I'm finding a distance, if I'm finding the distance along the horizontal line, I always take right minus left. Always right minus left. And if I'm finding distance along the vertical, the y, I always take top minus bottom. Always. No exceptions. That will save me a lot of work. So, two things that we need to get out of the way as far as coordinate planes. One of them is the distance between 2 points. So given 2 points, the distance between them is the change in the y plus the change in the x squared. And the midpoint between them is the average of the x's and the average of the y's. So example 2 states, a pair of points are given. Find the distance between them and the midpoint of the segment joining them. Alright, well, we're going to do both. To find the distance between those points, we say distance is the square root of y2 minus y1 squared. squared plus x2 minus x1 squared. The distance would be the square root of negative 6 squared is 36. 1 squared is 1. That's the square root of 37. So that's how we find the distance between the 2 points. And to find the midpoint, we simply take the average of the x's. So x1 plus x2 divided by 2 and y1 plus y2 divided by 2. The midpoint between those two would be 1.5 or 1.5 and 0. Fairly simple. And to find the distance on the next, well, distance is the square root of y2 minus y1 squared plus x2 minus x1 squared. And the distance would be the square root of, this will be all over 2, negative 8, negative 13 halves, plus a 1 squared, which is 1. So the distance will be the square root of 169 over 4 plus 1. That is the square root of all over 4, 173. So the distance will be the square root of 173 over 2. And to find the midpoint, you would simply say take negative 1 plus 0 over 2 and 4 minus 5 halves divided by 2. That would be negative 1 half. And if I take 4 minus 5 halves divided by 2, that's a complex fraction. If you find the LCD for the top and the bottom combined, which is a 2, if all of these fractions have the same denominator, you could ignore them and read the top. That would be 10 minus 5 over 4, that would be 5/4. That's the quickest way to simplify a complex fraction, something that's not going to go away. Now, the graph of an equation is the set of all points in the plane that satisfy the equation. The graph of an inequality is the area in the plane that satisfy the inequality. So, let's talk about inequalities. Sketch the region given by the set. Well, x is greater than or equal to 3. Let's go to 3. 1, 2, 3. X equal 3 is a vertical line. And if we figure out a point either in the region on the left, so keep in mind there are two regions, either this region or this region, because the line is going to cut the plane into two, that satisfy. If it's included, it's a solid line. If it's not included, that is, instead of an open circle, we show that by a dotted or dashed line. So x is always greater than to the right. You could pick a test point if you want, or you could just say, well, x is greater than, it must be to the right, so the region is from 3 and all the way to the right. And that will be your solution, that area. Here, it says y is less than or equal to 2. First things first, I want to go to y equal to 1, 2, and I'm going to draw my line dashed because it's not included. And when you say y is less than, keep in mind the positive is greater than and the negative is less than. So y is less than, that would be below. Of course, you could pick a test point to check whether that region is true or not, and the test point can be on the line, so the origin will work for both of those. This says x is between -1 and 3. So if I go to -1, I draw a solid line because it's included. And I'll go to 3 and also draw a solid line because that's also included. And when you say x is between, the solution set will be all of that area. Now this says x and y such that absolute value of y is greater than 2. Doesn't that mean that y is greater than 2 or y is less than -2? Well, it's not included, so y equal to a dotted line, -2, a dotted line because it's not included. When you say y is greater than 2, it will be that region, or y is less than -2, that will be that region. To find the x-intercepts, that is, where does the graph cross the x-axis, you'll notice all points on the x-axis have one thing in common. All of these points combined, every single one of them, has a 0 for y. You don't move up or down. So it's safe to say, to find the x-intercept, set y equal to 0, and algebraically you could figure that out. Now, to find the y-intercept, that is, where does the graph cross the y-axis, the same deal. These points have one thing in common. You don't move left or right. Whether it's positive or negative, it doesn't matter. So if I was to set x equal to 0, I'm guaranteed that I would be able to figure out the y-intercept. So on the next problem, find the x-intercept of each graph, just the x-intercept. Well, to find the x-intercept, find the intercepts. To find the x-intercept, basically what we do, we set y equal to 0. So x squared plus 3x times 0 plus 0 squared equal to 2. Well, those are all zeros. X squared equal to 2, which means x would be plus or minus radical 2. To find the y-intercepts, I would set x equal to 0. If I put a 0 there and a 0 there, I'll be left with y squared equal 2, and y would equal plus or minus radical 2. So here they're symmetric, they match. That's not always the case. The next problem, if I want to find the x-intercept, I would say set y equal to 0. Well, 0 will equal, if I factor that, that would mean x equals 0 or -3. So here they are. The x-intercept, I would give those as 0, 0, and -3, 0. It's always best to give it as coordinate planes, coordinate points. And if I look for the y-intercept, I would set x equal to 0. Well, if I put 0 there and there, I'll get 1 point and I'm done. So that part's fairly simple. If I want to find the x-intercept right there, set y equal to 0. Well, if I put y equals 0, I'll get x equal the square root of 9, which is 3, done deal. If I want to find the y-intercept, I would set x equal to 0. So if I put 0 there, I'll get 0 equal the square root of 9 minus y squared. Square root both sides. And if I square root both sides, don't forget you get a plus or minus 3. So that's how this works. We use the fact that anywhere you are on the y-axis, the x value is 0, and anywhere you are on the x-axis, the y-axis is 0. So we're going to stop this video and I'll pick that up in another, finish this section.